Hi, today we're going to be talking about succession in an Acadian forest, monitoring the effects of Hurricane Juan on Point Pleasant Park over time. Okay, so succession is an important ecological concept that describes the changes that occur within a community when it's exposed to a disturbance. Among the many disturbances that can induce succession, wind disturbance is one that is particularly impactful, as it can cause significant vegetation loss and severely disturb soil. A major source of wind disturbance is hurricanes, which, due to their ability to remove large portions of forest canopies and cause landfall, are one of the most important disturbances for forests in Atlantic Canada. Point Pleasant Park is an Acadian forest located in Halifax, Nova Scotia, which is one of the most highly populated areas of Atlantic Canada. The land holds great importance to the Mi'kmaq Nation as the site was traditionally a significant gathering place. Prior to 2003, Point Pleasant Park was declared an even-aged near climax community. Due to this even-aged nature of the park, there was a strong canopy but few young trees to buffer against winds, which, in combination with the shallow soil characteristic to Nova Scotia, ultimately meant that the forest was highly vulnerable to windfall. Hurricane Juan hit eastern Nova Scotia on September 29, 2003 with Category 2 force and wind gusts up to 185 kilometers per hour, making it the worst storm in Halifax history since 1893. The immediate impacts of the hurricane included the removal of over 70% of the forest canopy at Point Pleasant Park and the loss of about 70,000 trees. Since the disturbance of Hurricane Juan, the ecological community of Point Pleasant Park has changed greatly over time, and as we continue to gain more information about these changes, we can investigate the effects of succession over larger timescales. In this study, we're aiming to specifically look into the long-term effects Hurricane Juan has had on the overall forest community, the dominant species of the park, and the species richness over time.
Data was collected from 6 chosen sites scattered around the central and southern areas around the park. These sites were chosen based on areas that were most affected or showed most damage from the hurricanes. At each site, 20 by 20 meter area was sectioned with measuring tape, which was further divided into quarters to form 4 10 by 10 meter quadrats. Data was collected within these quadrats on percentage coverage of ground fauna and diameter at breast height of trees. To collect percentage cover of ground flora species, wooden 1 meter squared quadrat frames were utilized. Sampling areas were determined by throwing a random object, and where it landed became the center of the sampling area. This was done 3 times within each of the quarters for a total of 12 times. Ground flora species were identified with their percentage coverage within the sampling area. The diameter of trees were collected and identified within the sampling areas. Trees with a diameter of less than 2.5 centimeters were excluded from collection. Trees were measured at breast height, which was about 1.3 meters off the ground, with specialized tape, which allowed us to measure the circumference of the trees to determine the diameter.
We used linear regression analysis of overall density over time to understand the secondary succession occurring at Point Pleasant Park in the wake of Hurricane Juan in September 2003. A significant positive relationship was observed between the time and overall density, with a p-value, with a very small p-value, meaning that there is a strong evidence that density increases over time. As made evident by the trendline in our total density graph above, overall density has increased since, with the most recent years showing the highest density. These results mean that we can reject the null hypothesis and that there is a strong evidence that overall density of the plots sampled since Hurricane Juan has been increasing and is moving towards a climax community once again. There are a few reasons this has likely happened. First, post-hurricane, 30% of the trees in Point Pleasant Park were left standing. These trees likely provided a great base for which tree density could grow from in the years following. Additionally, the exposed soil resulting from the uprooted trees and the cleanup effort of the park post-hurricane would allow for plenty of space for which the seeds from these remaining trees could grow. Another reason for this density growth could be a lack of competition for space in the park, since 70% of the trees in the park were cleared. As the overall forest community moves towards its climax community, we can predict that biomass of early pioneer species will become less prevalent in the space and will make the environment more suitable for other species that are more tolerant to higher competition, since the focus will be less on disturbance tolerance and more on competition as density increases. Finally, we can predict that overall biomass accumulation will slow down as nutrient cycling becomes more increasingly efficient in the park.
In 2004, red spruce was the dominant species with a 3.25 average in density within the 400-meter squared sampling areas. As we can observe, over the 20 years, the species density slightly increases to an average of 8.8 in 2024. Not that large of an increase, but understandable for the nature of the species, as red spruce is a very slow-growing species, as they grow up to 25 meters, but only start producing seeds at 30 years old, meaning that the trees that survived the hurricane at Point Pleasant are currently the only spruces that are producing seeds, as the new generation is still too young. Over the 20 years, the red spruce population recovers slightly despite the competition of other tree species at the park. However, they are not the dominant species in 2024. With an average density of 31.6 within the sampling areas, red maple takes the title of dominant species, as they are fast-growing and reach reproductive maturity at 4 years old. We can observe a rapid increase in density just 10 years after the hurricane. If in the next 20 years there is no disturbance, many of the red maple trees will have reached maturity and dominate the canopy of the trees matching the height of the original red spruce. Many of the newer red spruce will have reached seed-producing age and contribute to the increasing population of red spruce. These species will reach an equilibrium where they have reached maturity and fully adapted to the changed environment after the hurricane. However, with red maple dominating the climax community. However, as this species is great at recovery, they are susceptible to wind throw, disease, and insects, making it unlikely that they will reach climax community within the next 100 years.
We also used a linear regression analysis of species richness in Point Pleasant Park over time to determine the effects Hurricane Juan has had on the ecological community of the park since it hit in 2003. Using species richness as a community metric, it can be determined that communities in Point Pleasant Park are recovering over time, as from 2004 to 2025, a positive relationship in species richness can be observed, with a p-value less than 0.05. Due to this information, the null hypothesis can be rejected that there will be no change in species richness in Point Pleasant Park over time, as the data prove that species richness has drastically increased across the sample areas over time, and that it is going to continue to increase. The results obtained by looking at species richness in Point Pleasant Park over time are fairly expected when considering an environment in a state of succession. The minimal richness in 2004 indicates that the disturbance caused by Hurricane Juan left very little species variety in the park. The species that were left were also likely pioneer species with qualities such as shade intolerance, high speed dispersal and reproductive rates, and the ability to live in harsh environmental conditions such as areas with poor soil and nutrient availability. The gradual increase in species richness then further indicates that over time, pioneer species have been able to recolonize the area and restore environmental conditions to ones that support more species variety, likely including more species that are persistent, long-lived, and shade-tolerant.
Based on the trends in the data and succession theory, we are likely in the earlier part of the middle stage of the Acadian forest secondary succession. We can see that the overall density and species richness over the past few years has stopped increasing as much as it was immediately after the initial disturbance, which is an indication that we have entered the transition phase between aggregation and steady-state phases of ecosystem recovery. Point Pleasant Park, being an urban park, affects succession in many ways. Part of the park's upkeep involves the removal of invasive species from the park. This assures the impacts of humans bringing in invasive species that could interfere with the natural selection will be minimized, since this is a popular tourist destination and there is potential for non-native species to be unintentionally introduced. Next, the existence of pathways in the park means that some seed distribution methods are favored above others, since it would be easier for unassisted and wind-dispersed seeds to make it across these paths than, for example, scatter-hoarded or ant-dispersed seeds. To close off, indigenous cultures have been practicing methods of ecology and forest recovery for almost 1,000 years now. One of these is two-eyed seeing, which is a concept brought forward by Mi'kmaq elder Albert Marshall in 2004, which refers to seeing a concept from both a scientific point of view and an indigenous point of view. This could lend itself very useful to the recovery of Point Pleasant Park back into a mature Acadian forest, as we can learn to both integrate ourselves to work with the land as well as encourage it with scientific processes. We would like to thank Dr. Joanna Zaguris as well as the demonstrators of Class Biology 2060, especially Jovia Gallant, for the logistic help they provided in data collection in the field. We are also grateful for the help provided by every student that helped collect data on this project since 2004. Additionally, this project would not have been possible without the constant upkeep of the park, a service provided by the Halifax Regional Municipality's Point Pleasant Park team. Finally, we would like to acknowledge that the land on which this project took place is on traditionally Mi'kmaq territory.